Okay, so I want to go back to Excel and look at finding the mean and median, and then I want to show you how to create a graph called a histogram, which is going to visually let us see some of these properties. So I've gone in and I've put all these numbers into Excel already, and I'm going to have it calculate the average, which we'll define as the mean, and then we'll do the median. And turns out they're the same. And then we're going to create something called a histogram. So let me highlight this. Now, in your spreadsheet program, you might have to Google search this to kind of make sure that each program does this. But we're looking for something called a data analysis option. For right now, it's under data, and you might not have it there, but you can activate it. So if you don't see the data analysis button under data, just go to File, look for Options, and under Options you want to look for Add-ins. And these are just programs that Excel has that aren't activated all the time just because for whatever reason. And then just make sure it says Data Analysis Tool Pack, and then click Go, and it'll give you the option to enable it or not. Okay, so now that you've got it enabled, or theoretically you do, we're going to go to Data Analysis. I'm going to click on Histogram, and it's going to ask me for the input range. So I'm going to highlight all those numbers. Bin range is well, we're not going to worry about that for right now. But I do need to worry about output. So output, I'm going to just click on a particular cell, and I would like a chart output. So I'll click OK. And it gives me some interesting numbers there. But it also gives me sort of a graph that we can look at how the data is behaving. So okay, so I just want to speed this up so we can get to the other data types. So using Excel or using your calculator or other programs you have access to, if we type those numbers in and find their means, we get a graph, I'm sorry. We get a mean of 28.176, a median of 25, and clearly we have right skewed data, and so we can see that the mean is towards the direction of the skewness, whereas the median isn't. Okay. Then we'll do this last data set. So same thing, type in the numbers into some sort of technology, and we get the mean and the median and the graph. So the graph looks about like this, sort of closer to left skewed, and we have a median of 58, a mean of 54.5, and then clearly it's left skewed, so the mean again is pulled in the direction of the skewness. So what does this all mean and why does it matter? When you're asked to give an average, you really do need to consider the type of data the type of graph the data represents. If the data is symmetrical, the mean and median should be equal, in which case we would give the mean as the average of the data. And in a skewed distribution, the mean and median are different. The mean is pulled in the direction of the skewness, and so we would talk more about the median. Okay, so one more time in case we didn't catch it. In a symmetrical distribution, we give the mean for the average. In a skewed distribution, we give the median as the average. Okay, so let me kind of hit home with a real-world example as to why mean and median are important as far as averages are concerned. Newspaper surveys wages for assembly workers in a regional high-tech company and reports an average of $22 per hour. The workers at one large firm immediately request a pay raise, claiming that they work as hard as employees at other companies and their average wage is 19. The management rejects this request, telling them that they are overpaid because in fact their average wage is 23. Can both sides be right, and why? Okay, so the thing to note, just as we're looking at this, is they use the word average for both numbers. So that's kind of what we're thinking about. Is it possible that two groups of people can look at the same numbers and come up with different representations of their average? So for this, we're going to come up with some sort of fake numbers for some workers, kind of illustrate the difference between the two. Okay, so again, this is hypothetical, but let's say of our 5 workers, 4 of them are all making $19. One guy is making 39. Again, I just made these numbers up, so please don't stress about how did you know. Let me get the median of the data, and as you can see, since 4 of the numbers are the same, the median is going to be 19. But let me get the mean of the data as well. Okay, and so you can kind of see that there is a difference between the two numbers. One, the median is 19, and the other mean is 23. Clearly, 4 of the 5 people are dissatisfied, and only one guy's like, I don't know what the problem is. I got $39 an hour. So yes, it is possible that the same group can be looking at the numbers and come up with 2 different averages, which means that they should have a conversation about which average is the most appropriate. In this case, you'd have one extreme outlier and the mean is pulled in that direction. So I think the median should be used, but you definitely want to consider the type of distribution of the data.